we are trying to create a wearable that can be a Fitbit for your brain in a way that when you are feeling anxious or stressed, we can track these markers.
This is Lightbulb Moments by USC, a podcast capturing moments of brilliance happening across campus. I'm Jessica Peretta from University Communications. In this episode, I'm talking with Yasser Khan, who is creating a new generation of wearable technology. He gives us insight on how these devices will create a more precise picture into our health and wellness. Yasser talks about his work as an engineer in the healthcare space, what it takes to push a new idea forward, and what the future holds for human-centered technology. Which of your devices that you've created, which one is the one that you're most excited about?
The field is quite mature, and there are many commercially available wearables. You have Fitbit, Apple Watch, Samsung has the Galaxy Watch. And in a way, most of these wearables, they measure activity levels, and they're being used for knowing your fitness. What we are very interested in now is to use this wearable technology to understand mental health and also track brain and behavior. So after starting at USC, we are now looking at what are the biomarkers that we can track using non-invasive. That means it's not gonna be under your skin. And these biomarkers can track mental health.
And can you give us a little example of what biomarkers are for people?
Of course. So typically biomarkers are physiological signals or chemical signals. For example, let's say you can measure your heart rate or measure glucose, and that will be indicative of what your body is going through. So similarly, we have identified few biomarkers that can be measured using this wearable technology, and they do relate to your mental states. So essentially, we are trying to create a wearable that can be a Fitbit for your brain in a way that when you are feeling anxious or stressed, we can track these markers. And if you are using this technology, for example, to measure wellness, the AI can tell you, okay, it's time to take a break. You are exhausted. And now we are trying to push the boundary, merging different sorts of biomarkers. For example, people have looked at physiological markers, skin conductance, the Fitbit Sense right now measures skin conductance, and also heart rate variability. Heart rate variability is essentially looks into the nervous system. In the nervous system, you have sympathetic and parasympathetic nervous system. When you get stressed, usually the sympathetic nervous system kicks in. And heart rate variability measures your balance between the two nervous systems. So these have been explored somewhat in the literature and also in the commercial devices. We are also interested in chemical markers. And one of those chemical markers is cortisol. That means we can have a combination of physiological and also chemical markers that can give you your mental state. And the whole thing can be done with a wearable device. The challenging part was to create this chemical sensor. This work essentially started during my postdoc, and since it's so complicated, it's been taking a while. And I would quote my postdoc advisor. So she typically says the stress hormone cortisol, it's so low in quantity in the body, and the fluctuations are also very small. For example, if you take a Olympic-sized swimming pool, you drop 2 pinch of salt, the change between the 2 pinch drops is what we are trying to measure. It's very, very small. So that's why you need a very sensitive chemical sensor. And merging the work I have been doing in my postdoc and also in this new lab, now we have the combination that is working well. And recently, we are working with USC folk in both engineering and also School of Medicine to make this device more mature. So we are basically working on the next generation of wearables that will track both brain and behavior.
Including technology into our health, right? And having this become more prevalent. Why are we doing this? Why are you doing it?
Yes. So we are moving towards precision medicine. And I will use the example of ingestibles. For example, excuse me. For example, let's say if you're taking medication, right now we don't provide dosage based on the individual. Like you take a medicine, you take a capsule, it is providing a blanket dose, but that may not be necessary and it has side effects. To create a platform where you will be using medication where it's necessary, you need to know what is happening in the body. And here, some of the tools we are working on will be very useful. For example, if you have a ingestible device, a capsule that goes in the gut, measures how much is needed, and then specifically delivers that amount. That will be super powerful. And even for, let's say, dealing with very serious illness such as cancer, when doing chemotherapy, we just use a blanket dose, goes to the body, has a huge amount of side effects. But let's say if you have a intelligent device that goes into the location of interest and then specifically delivers the drug, that will cut down all the side effects and you are only getting the benefits. And I think the field is moving in this direction. We do have many of the solutions they're very specific, they're targeted, they're precise. And if you get data from the wearables, injectables, implantables, even implants, brain implants, we can treat illness based on the person rather than doing a population study. Right now, we judge based on what happened to people previously, and all the treatment planning is based on what we have seen before. But if we are measuring at that specific time what is happening to the body, what is the need, and then we can precisely deliver the medication, that will be very useful And that is what we are now trying to do in precision healthcare.
And what do you think is one of your biggest challenges or obstacles that you faced in your career and you feel like you had to really push through?
It's getting the trust of people who funds your work. So typically, all this medical device work needs significant amount of resources. When you have a problem, you are very passionate about it. Convincing others to believe that that is the problem and the solution you have at hand may work is extremely challenging. So I have been trying for the last few years to create a network of sensors that looks at the brain and the gut simultaneously. But if you look at the complexity, it's enormous. For example, creating a brain implant needs a humongous amount of resources, while tackling the gut is also another beast. Like you have companies doing this type of work, but what I was trying to do is trying to create like a very small sensors that can be implanted in the brain and also can be swallowed, so we can record the brain gut activity in real time. Initially, it was a struggle to convince anyone to believe in this work. But fortunately, last year, I got the Packard Fellowship. And it is like one of the biggest early career supports. It's not just the support, it's also the trust of the foundation to support our work. That was like a change, basically, that changed my trajectory. Now we have the resources and also the belief of the community that this is a problem worth pursuing, and the solution we are providing may work. It may take many years, but I am hopeful, my team is hopeful, that we will be able to create these ultra miniaturized neurotechnologies where we can look at brain activity and the gut activity in real time. In a way, we will be creating a non-invasive window to the brain, because the gut is called the second brain. So if you can put medical devices in the gut, it reflects what's happening in the brain. So we are now creating these neurotechnologies that can measure neural activity in the gut. And since we can measure in both brain and gut at the same time, we'll be able to create a correlation of what is happening in this network. And that can be super powerful in looking at neurodegenerative diseases, and also like can be super powerful for people working on gastroenterology. Like it has enormous application space, but the technology didn't exist, and we are trying to create this technology.
A lot of people have thoughts on private companies doing this research versus academia. What is the benefits of having that?
For me, I think the biggest difference is the incentives. If you are running this research from a company perspective, you are motivated by the profit. And if you're doing from the academic perspective, it's solving the unknown. We are motivated more by the unknown and the science behind what is happening and creating exciting solutions. rather than driven by what is the market need. Eventually, it will translate. So usually, like if you look at all the moonshot research, it came from academic work. In academia, we can target a problem that is far beyond. For example, the solution can be 20 years in the working. But in industry, typically you try to solve things in 3 to 5 years timeline. So that limits your the horizon. And for us, we can look into the science, what excites us, and try to unravel the mysteries. And I guess like that is the fundamental difference. Like here, we don't have a ceiling. We have the boundless questions, and we try to answer them rather than looking at what is the market need and what kind of profit we can make it out of it. But eventually, if you run with this type of like blue sky research, they do provide solutions that industries use. For example, like the brain implants. The companies, they are using solutions that are coming from academia. All of the components the industry are now using, they have been in the works in academia for the past 2 or 3 decades.
What would you say makes you feel accomplished in your career?
So I teach a introductory class in electrical engineering, and there we are trying to bring the students really close to the solutions they are going to work on. For example, like we have projects where they are building engineering solutions. For example, like they're creating sensor systems. Whenever they finish a project, I see the spark in their eyes. And that is extremely rewarding for me. And I guess like training the next generation of engineers and scientists, that is like, when I started my position at USC, like I thought research would be the only thing that pushes me. But I am finding a very big joy in teaching too. And like when I see students, they're super excited about engineering, science, and they see what they have designed works. I had a student come up to me, and then like he told me that his life goal changed when he saw the first lab worked. Like at the beginning, he didn't think he's gonna become a researcher. Now he is planning to become a researcher. So that is like the reward that drives me. Apart from all this research, now I'm finding joy in teaching, also mentoring students.
Amazing. Mm-hmm. Well, thank you so much for speaking with me.
Thank you so much. I hope like everything worked out.
Thank you for listening to Lightbulb Moments by USC. You can find this podcast on Spotify, Apple Music, YouTube, or wherever else podcasts are found.